This is Dr. Naga Prasad, Assistant Professor, Department of Chemistry. Today, I am going to discussing about hardness of water. So, next types of hardness and units of hardness, and next water treatment methods. Before going to the topic, first of all, we have to know what is the hardness and what is the reason for hardness. The property of water does not produce lather with the soap. That is known as hardness. So, hardness is due to the presence of some salts like calcium carbonate, magnesium carbonate, and calcium bicarbonate and magnesium bicarbonate. So these all salts are considered as a carbonates, bicarbonates, sulfates, and nitrates of calcium and magnesium. So due to the presence of these all salts causes phenomenon, that is absence of lather when reacting with soap. So that is a property of water. So that is a definition of hardness of water. So water does not produce with lather is known as hardness of water. So next, coming to the type of hardness. Depending on type of salts present in water, hardness classified into two types. That is temporary hardness and second one is permanent hardness. Temporary hardness is due to the presence of bicarbonates of calcium and magnesium. Temporary hardness due to the presence of bicarbonates of calcium and magnesium. This type of hardness can be removed simply by boiling. When you are boiling hard water which contains temporary type of hardness producing salts like calcium bicarbonate and magnesium bicarbonate forms calcium hydroxide and magnesium hydroxide precipitates. So these are simply removed through a filtration process. That's why this type of hardness we can call it is temporary type of hardness. So what is a permanent type of hardness? This is due to the presence of except bicarbonates of calcium and remaining calcium and magnesium salts. Remaining all type of salts causes permanent type of hardness like calcium carbonate, magnesium carbonate, calcium sulfate and magnesium sulfate, etc. Except calcium bicarbonate and magnesium bicarbonates. Except bicarbonates of calcium and magnesium causes permanent type of hardness. So look at here. When you are taking hot water in a two beakers, one beaker contains excess of calcium and magnesium ion, and second beaker of water contains less number of calcium and magnesium ions. So when comparing these two types of beakers, hardness is more in first type of beaker and hardness is less in second type of beaker. This is the limits of hardness. So usually hardness is we can measure in ppm units. So 0 to 60 ppm water, that is soft water, and 60 to 120, that is moderate hardness of water, and 120 to 180. In between the 120 to 180, that is hard water, and 180 plus. The ppm of water is 180, more than 180 ppm, that is considered as a very hard water. Next, coming to the how we can identify hardness. By simply we can identify the hardness by using soap test. So what is a soap? Soap is a sodium potassium salt of higher fatty acid like stearic acid and boric acid. Sodium or potassium salts of higher fatty acids. Let us consider some stearic acid. Sodium stearate. So molecular formula for stearic acid is C17H35 COOH. So one hydrogen is replaced by sodium, that is known as soap. Sodium stearate. So sodium stearate is known as soap. Okay, so soap when react with calcium and magnesium forms insoluble scum, that is known as soap test. So if the water when react with soap forms insoluble scum, that is considered as hard water. Next, how we can express the hardness. So hardness we can express in terms of calcium carbonate equivalence. Why we should take calcium carbonate as a standard to express hardness? So main reason for to express hardness in terms of calcium carbonate, that is the molecular weight of calcium carbonate is 100 and gram equivalent of calcium carbonate is 50. So it is very easy when these are the whole numbers. When you are solving problems of water technology, make it very easy. And it is highly insoluble salts, can be precipitated in water treatment. That's why we have chosen calcium carbonate as a standard to express hardness. Next, coming to the types of hardness. Temporary hardness. Depending on type of salts, hardness is classified into two types. They are temporary hardness and permanent type of hardness. So let us see first type of hardness, that is temporary hardness. This is also known as carbonate or alkaline hardness. It is due to the presence of bicarbonates of calcium and magnesium. It can be simply removed by a boiling. When you are boiling hot water which contain salts which causes temporary, so this is a reaction. So calcium bicarbonate and magnesium bicarbonate, and boiling forms calcium carbonate. Down arrow mark indicate precipitate. This calcium carbonate and magnesium hydroxides are formed as a scums. Scums are nothing but precipitates, insoluble precipitates. So these substances are simply removed through a process of filtration. That's why the type of hardness arises due to the presence of calcium bicarbonate and magnesium bicarbonate is known as temporary type of hardness. Next, coming to the second type of hardness, that is permanent hardness. This is also known as non-carbonate hardness, non-alkaline hardness. So it is due to the presence of chlorides, sulfides, and nitrates of calcium and magnesium. It cannot be removed by a boiling of water. there are some separate techniques have to use to remove permanent type of hardness producing salts from a water. That is lime soda process and zeolite process and ion exchange process methods are few methods to remove permanent type of hardness from water. So this is an expression of hardness of water in terms of calcium carbonate. So amount of calcium carbonate is equal to X into 100 by molecular weight of hardness producing salt. Here X is the amount of hardness producing salt into 100 by molecular weight of hardness producing salt. Next, coming to the units of hardness. Usually, units of hardness, there are 4 types of units: ppm, milligrams per liter, degrees of crack, and degrees of French. So ppm stands for parts per million. Parts per million. The number of parts of equivalence of CaCO3 hardness causing salt present in 10 to the power 6 parts of water is known as ppm. Next, coming to the milligram per liter. It is a number of milligrams of equivalent of CaCO3 present in 1 liter of hot water. Next one is degrees of crack. It is a number of equivalent of CaCO3 present in 70,000 parts of water. And next one is degrees of French. It is defined as number of parts of CaCO3 or equivalence as present in 10 to the power 5 parts of water. And there is some interconversion in between the units of hardness. That is 1 ppm is equal to 1 milligram per liter. That is equal to 0.07 degrees of crack. That is equal to 0.1 degrees of French. Next, coming to the water treatments. By using these technologies, we can remove the permanent type of hardness. First one is zeolite process. So what are the zeolites? Zeolites are microporous 3-dimensional crystalline solids of aluminum silicates. Sodium aluminum orthosilicates are known as zeolites. So zeolites have small openings of fixed size in them, which allow small molecules to pass through them easily, but larger molecules cannot pass through them. So there's a resin type of structures. Zeolite has resin type of structures and some type of zeolites, that is Aeronite, Gemirinite, and Jerusalem 5. These are all sodium aluminum silicates. By using these zeolites, we can remove the permanent type hardness producing salts from water. And some natural zeolites, that is crinoterroate, have a silica to aluminum in the ratio of 5 to 1. It does not break down in the middle of acid environment and is broadly used in the agricultural industry as a feed additive and soil amendment. And second one is phasacite. It's another zeolite. And coming to the chemical composition of zeolites. So all zeolites made up of aluminum silicate framework, where silicon and aluminum are tetrahedral coordinated. Their silica cation and aluminum cations are enclosed by 4 oxygen anions. The tetrazeolite formula is given by mx by n AlO2 x SiO2 y MH2. Zeolites tend to have a different chemical elements in their composition. The formula for zeolite is given as ratio where M any one of matter, that could be a magnesium, sodium, potassium, lithium or calcium. N is the valency of the metal cation and Y is the number of water molecules in a structure of the zeolite. So Y by X is equal to atomic silicon by aluminum ratio. Silicon aluminum ratio. Y by X indicates silica aluminum ratio. So next coming to the properties of zeolites. So zeolites are very stable solids under different environmental conditions. The melting point of zeolite is very high, that is 1000 degrees of centigrade. They are insoluble in water and other inorganic solvents. They do not undergo oxidation in the presence of air. And the characteristic properties of zeolite is its open cage-like framework structure that helps zeolite trap water and ions of potassium and calcium. The natural form of zeolite occurs in the random forms and pore sizes are not uniform, whereas synthetic zeolites are synthesized in a very precise manner with uniform pore size. So this is a schematic diagram for water purification by using zeolite process. So apparatus consists of some vertical tank, some vertical sand tank. Some zeolite is placed in middle of the tank. It is connected with another tank that contains concentrated NaCl. When you are passing hot water into the tank through an inlet, when water contains different types of salts of calcium and magnesium. When water penetrates through the zeolite bed, some ions of the water will be replaces. This process carried out for some time. Zeolite contains cations and anions of hot water. If you want to purify and further, so there is no possible of purification. Why? Because zeolite bed contains only cations of calcium and magnesium salts. So that's why the zeolite bed has to be exhausted. It has to be regenerated. How it will be regenerated? By passing sodium chloride from second tank to the zeolite tank. That is known as regeneration step of zeolite. So look at here. So when you are adding hot water to the tank which contains zeolite bed, forms calcium zeolite or magnesium zeolite, and So this process carried out for some time. After that, zeolite will be exhausted and it has to be regenerated. Why it should be regenerated? After formation of calcium zeolite and magnesium zeolite, there is no chance of further purification of water. Why? Because here there is no sodium zeolite. Sodium zeolite. That's why it has to be regenerated. How it will be regenerated? By passing sodium chloride. By passing sodium chloride into the zeolite tank. So sodium zeolite has been regenerated. Now you can purify the water by using zeolite tank. So that is the process of purification of water by using zeolite. And next, coming to the advantages. So what is the advantages of zeolite process? By using zeolite process, we can remove the hardness up to 15 ppm. Water which is purified by zeolite process is very clear and very pure. Equipment is compact and hence it requires less space and it requires less skill in maintenance as well as operation. The process itself exists for different hardness of incoming water. So coming to the limitations of zeolite process. By using zeolite process, we cannot remove the both cations and anions which causes hardness to the water. That is the main drawback of zeolite process. And one more is highly acidic water is not suitable because it affects the minerals. Zeolites of iron and manganese cannot be easily regenerated. Raw material must be free from suspended impurities. The water should not be turbid. So these are the disadvantages of the zeolite. So that's it. That is about purification of hardness by using zeolite process. So zeolite is nothing but sodium aluminum silicate. So with the help of zeolite process, we can remove the hardness producing cations, especially cations of we can remove. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.